That's the switch for me. And when I look at every customer problem that I encounter, it's always a strategy problem.
Yeah.
And as soon as I can get them back to caring about either how this impacts their job or push senior leadership back into managing value creation, as soon as I can do those, everything gets so much easier.
Hello, everyone. Welcome to the Data Scientist Show. Today we have Vin Vashishta. Vin is the Chief Data Officer and AI Strategist at V Squared, a company he founded in 2012 that provides AI strategy, transformation, and data organizational build-out services. He teaches data professionals about strategy, communications, business acumen, and applied machine learning research methods. He has 130K followers on LinkedIn talking about AI analytics and team building. And if you have been enjoying the show, subscribe to the channel and give me a 5-star review. Welcome to the show, Vin.
Thanks for having me. I really appreciate it.
Yeah, so I saw that you studied physics in college. How did you get into machine learning?
I actually went to school for computer science, and so I graduated with a degree in computer science and physics. So I thought I was going to graduate and go straight into doing data science, machine learning. There was a grant at University of Nevada, Reno, where Microsoft gave us about $1 million to teach data science and machine learning to people like me. So I thought I was graduating, going to work for Microsoft. I was gonna no, that was that first wave in the '90s that fizzled out. So I ended up taking jobs in software development. I installed computers to begin with, and then got into QA, led a QA team, got into software engineering, led a software engineering team, led a cross-functional organization, and then 2012 got laid off and started V Squared. It was kind of one of those, oh, I have clients. Oh, I have I can do this data science. It's come back around.
Mm-hmm.
Saw it really in the analytics BI side in 2010, got back into data science and machine learning. And then after the layoff, I thought, I want to do this for a living. So
Yeah.
that's when I opened up V Squared, landed a couple of large clients, got lucky that they wanted me to do some supply chain logistics type analysis and then build some models around that for optimization. Moved on to doing behavioral modeling around marketing, some pricing models, and it's been a crazy 10 years in data science and machine learning, kind of
Yeah.
fixing things and learning as I went. Ended up learning that you can't do data science and machine learning if you don't get a significant budget for it.
Mm-hmm.
So that's where I got back into the strategy side of the house because I was looking at becoming a product manager in 2010 as well. It so brought the strategy side of it back, introduced business strategy and data science, and it works. It worked really well for large clients. Now I do it with SMEs, startups, pretty much anyone who wants to make money off of data science and machine learning. I'll introduce the strategy side and then take a project from
Mm-hmm.
zero to production. It's
Yeah.
been, like I said, 10 years. It's been a great ride. I love this field.
Yeah. Thanks for sharing that. That's quite a journey. So, when we think about strategy, it sounds very abstract. Can you give us more details and examples about what is the strategy you're talking about?
So I define strategy as the study of leverage and advantage in competitive zero sum games. Because when you define it that way, you can see the connection between data science and what we do and what strategy does. Strategy informs decision making. And for a business, strategy creates many paths to success. Companies that don't have strategy, that simply do planning, have one path to success. And if that doesn't work, they're out of luck at that point. And so the importance of strategy is to give a business multiple paths to success. And the business wants to be able to evaluate opportunities. And when you begin to look at it as leverage and advantage, companies are looking for opportunities where they have some advantage, where they have a lever that they can pull on
Mm-hmm.
to create an advantage over competitors when they're going after a particular opportunity. And so with data science, when you bring that into the equation, you help decision makers, senior leaders understand how to evaluate opportunities more rigorously.
Mm-hmm.
You go from, assumptions, case studies, to something that's more data driven, and then eventually something with a higher level of evidentiary support. That's how you prove out the value of data science. You give it to senior leaders, they begin to use it, and they say, oh, wow, this is useful. And then you can
Yeah.
justify cost savings initiatives. And you
Hmm.
begin to show other organizations, hey, this saves you money, this makes your job easier. They start to love it, and you say, well, why don't we do some products? And you can begin from there. You've proved out that the technology works internally. Now they're ready to trust it enough to give it to customers. And so you start with features and move from features to complete products that are based on models and inference. And it's that progression. And so that's the technology side of strategy, where you begin to support senior leaders, you begin to support decision making, because that's what strategy does. It informs decision making. And you go from there to gaining trust internally. Then you gain trust of customers. And then you can give them the keys to the kingdom. They trust machine learning models to work in their products. So you can give them increasing functionality. They trust it, they'll trust more. And that's the
Hmm.
progression. And that's why strategy is really important to data science.
Yeah. Thanks for sharing that. And I really like a LinkedIn post you wrote. You said, business remember the value we create, not the technology we use to create, and people buy solutions, not data science. I think strategy is not something business leaders should care about. For data scientists, if you want to really drive impact for your employer or for your career, you should think about strategy. So I think you gave us a pretty good walkthrough on what is strategy. I know you also teach courses. Do you have any case studies you can share with us, for example, in a specific maybe forecasting or some use cases? What are some challenges and how can we use strategies to implement those type of solutions?
We can definitely share a ton of different case studies.
Yeah.
Now, I got to think of which one's the best one to share. Um, a really simple one. Amazon uses machine learning for pricing. They've automated pricing decisions. And one of their KPIs now is the percentage of pricing decisions that are automated. And that tells you the power of machine learning and the machine learning behind those models, because they've realized they've gotten this pricing to the point where the accuracy is so great that they want to begin to turn over from people, because you can't hire enough pricing analysts to handle Amazon's catalog.
Yeah.
There's just too many products. So they now measure the percentage of pricing decisions that can be handled by machine learning. And that, when you talk about a use case, that's really because we think about it from the technology side. And from a use case standpoint, they don't care about anything else except, is it accurate enough for us to trust, and then begin to turn over some of the work that we do. And that's the concept of human machine teaming, where we begin to trust data science and machine learning, and we begin to hand it off. Some of the work that we do, it's part of the team now. And that's when we talk about use cases and strategy and the business side of it.
Hmm.
You heard, I didn't say anything about the technology.
Yeah.
Nothing about the model, nothing about accuracy, nothing about any of
Right.
that, because they don't care about any of those measures. When they get to the point, though, that they're saying, okay, I want to continuously improve and increase the number of pricing decisions that we can use and automate, use machine learning
Hmm.
for, there's trust there. And now my side of the job is to continually improve the model so that it can handle more and more pricing decisions, so that it can automate more and more of these types of decisions. And so I have a business metric that I'm continually working towards that guides everything that I do on the applied research side and on the data science side.
Yeah.
And senior leadership has that number. They don't care about anything behind it, all that complexity. It's
Yeah.
one number that they're looking at, percentage of pricing decisions automated. And that's
Hmm.
when you talk about a use case, that's the power, is one number. And the business is able to do everything that they do without much of a change to their workflow and to the way that they make decisions. And as data scientists, I have a single metric I'm shooting for.
Hmm. Yeah, that's a great example. So when you have that one metric as a North Star metric, do you get involved in creating that metric? Do you give feedback? Oh, does it make sense? So how do you know whether this is the right metric to work for?
So the journey of KPIs in businesses, I hate to say it like this, but I'm just going to be blunt. The KPIs in early maturity businesses are horrible. They're not,
Yeah.
none of them work. They're all based on assumptions. We think this is going to, if we stare at this one metric, we think this metric does what we, does this other thing over here that makes us more money or saves us money or gets us new customers. And there's this assumption. What data can do, even at the very earliest stages, is begin to challenge that assumption and say, okay, well, I have data that says this metric has this level of connectivity. And that's, when you say that golden metric, what they start out with is their golden metric. And I have to reveal that their golden metric is at this level of connectivity to what they really care about.
Mm-hmm.
And this new metric actually has a deeper connectivity. So that's the way that I'll usually frame it and present it is now we have better data. We're gathering more data about this process that you care about the connection between this metric and an outcome. And that's the beginning of decision support is we've
Mm-hmm.
now changed the way you look at metrics. You don't look at them as forever things. We look at
Yeah.
them as, well, we got a better one now. Well, that's awesome. Yeah, we should use the better one.
Right.
And then, next month, I might bring you an even better one. Or I might bring you a second one where if you use
Mm-hmm.
these two metrics to make your decisions, you'll make a better decision. How do we know? Remember, we connected it to an outcome. And it's this loop, this continuous improvement loop, and changing the way people make decisions, making them go from, I'm going to use heuristics, which is, my assumptions that if you're an expert, you're pretty good. And now, in order for me to introduce a new metric, to change that golden metric, I have to be better than you. I have to actually figure out something that you don't know. Otherwise, why am I giving you different data? And
Yeah.
there's this threshold where I assume you're an expert. I assume you are smarter than any model I can create. And
Mm-hmm.
until I can give you something that teaches you something new, that brings new knowledge into the business, I'm just going to shut up because I have nothing, I have no value to add. And that's the process that I've always used when I introduce new metrics, new KPIs, is there's an outcome and that's all anybody cares about. And let's talk about the connectivity between this number and that outcome that you care about.
Yeah. That's a great point because the metric behind the metric, there's a outcome. There is
Mhm.
a, say, customer experience or profit. There's only just a few elements. So if you find a better metrics to measure that serving your goal, you can challenge the beginning assumptions. So I think data science should understand more about why this metric is defined and don't just take it for granted. Like you mentioned, the more you dig into the data, understand the use case, maybe you realize, wait a minute, you're not measuring the right thing, and that might not move you to the right direction. So now you have the metric, and then you need to translate the business problem to a data problem, sometimes a machine learning problem. Sometimes you might not even need machine learning. So, what is your process in this translation side?
Well, that metrics, the beautiful thing about the metric and the outcome is that's the translation. When we talk about the pricing example, that one metric, percentage of pricing decisions automated, that's
Mm-hmm.
my metric. That everything from my model must connect to that. So if I improve the accuracy of this model, does it allow me to make more pricing decisions? Because if it doesn't, who cares? And you begin to realize accuracy is this really terrible metric.
Yeah.
Because if I'm only making the decisions that I'm already making, those pricing decisions that I'm already making, if I'm just focused on making those more accurate, I'm not achieving anything with that metric. That metric's not moving. I'm still making the same number of decisions. I'm just doing it a little bit better. And so my objective isn't being achieved. And
Mm-hmm.
that's like I said, that's the power of those metrics is okay. So I'm not focused on accuracy anymore. I want to be able to handle more classes of products to price more appropriately across those products that I can't. And that guides your data gathering. Now you understand, okay, do I have enough data about them to make accurate pricing
Yeah.
decisions? Probably not. Okay, I need to, but what data is missing? Why do I have data about all this other stuff, but I don't have data about this? And you begin to understand problems as systems, not as models, not as data. And when you begin to take a systems thinking approach and look at them as complex systems, you realize that it's the dynamics of the system that I'm trying to simulate, that I'm trying to model. And so the data that's most important isn't about the initial configuration of the system and then some label at the end of it. It's about the system itself. Why do we price things? What makes something a good price versus a bad price? You begin to realize it's okay, it's the customer. Okay, it's, supply chain. How much did this cost me? How much will it cost to ship? It's marketing. How much did it cost me to acquire that customer, to get that customer to realize that there was this product that they could buy?
Yeah.
And it's everything else. And you realize it's this complex system. And
Hmm.
that's one of the reasons why pricing I mentioned at the very beginning, because it touches every area of the business. It touches competitors, it touches customers, it's everything. And when you start looking at it from the perspective of a system, you see that the reason why you can't price certain products well is because you're not missing data about the product itself. You're missing data about the business. You're missing
Yeah.
data about the customers and the competitors and how customers make a buying decision. Why do they look at your price and say, yes, that one, I'm going to buy that one? Are they price sensitive? Are they prestige sensitive? Are they prestige seekers? Are
Hmm.
they looking for something intangible that's outside of the price? So the price itself really doesn't matter. Maybe there's something else that's behind it. Because if you look at, designer names, no one's buying a Louis Vuitton for the price. No
The
one's looking
leather.
at that price point and
Yeah.
saying, well, if you're willing to come down a little bit, it's just not that's not the main consideration. It's a
Right.
prestige seeker. And so
Hmm.
you have to begin to understand that the pricing is the pricing. And the more important thing is to increase the perception of value for customers to your product. And so you have more people who are able to afford that premium product who will choose it, who will look at that and say, versus Hermès, I'm going to choose Louis Vuitton because I believe it has a higher perception of value. It has a higher prestige to it.
Yeah.
You start seeing that like you think pricing is everything, and it's such a minor component. It is a emergent behavior. The fact that someone takes a price or accepts a price is an emergent behavior of a much more complex system.
Mm. Yeah. It's related to branding. It's related to supply chain, and marketing and sales and all of it. So if you think about this data science problem, it's not just a data science problem. From the engineering perspective, like you mentioned, it's system.
Mhm.
And from a business perspective, it's entirely how a business operates. So once we have this type of understanding, we can, go into more fine grains to decide what data we're going to collect, what model we're going to build. So now, is it a time for you to start iterating models, and what is the process for you to actually find the right solution, the
Well,
technical
your model is
solution?
your hypothesis.
Hmm.
And most people think model is done. No, models that's step one. You're not
Yeah.
even you aren't even ready to deploy to production when you've trained, tested, and validated a model. That's unreliable. You've built something that if you want to use it for descriptive analytics or descriptive modeling to tell people this is what happened. This is, what happened in the past. These are events that have already occurred. Here is a description of those events. That model is excellent. Does a really good job of doing that. But then we have users who ask us to use the model to predict something. The model can't do that because
Yeah.
it is based on historical data. It is a representation of the data in a different form. So we have a metric that we're shooting for, and we want to move that metric. So in the pricing example, we want to not only predict optimal pricing, we are going to prescribe, because now we are taking some agency away from a person. And so we've gone from a descriptive level of evidentiary support to a predictive level of evidentiary support to a prescriptive level of evidentiary support.
Mm.
And there's all these steps on the other side of model development because models are excellent hypotheses. So I have a
Yeah.
hypothesis and I need to now take the next step and
Hmm.
do validation that requires, when it's predictive and prescriptive, I have to use experimental methodologies, not statistical experiments. I have to do like real study design. I have
Yeah.
to go beyond your basics because inside of my data, inside of my model, there are assumptions. And what my model does is it extrapolates those assumptions into the model itself. It creates a concept graph inside of the model. Especially deep learning models are very good at doing this. And
Hmm.
when we have these massive, massive amounts of data, that concept graph, that ontology becomes very complete because
Yeah.
we have all of the examples that we need represented to handle so many different classes of behavior in these really ridiculously sized billion plus parameter language models or large scale models for anything. But in most cases, we don't have that much data. We don't have enough data to, to really use those. And what we have to do is then supplement the observational studies we do to build models with more rigorous experimental methods to validate the assumptions that come with our models and come with our data. And we start to get into your causal methods, where you begin to start assessing the strength of the evidence supporting a relationship between variables, these assumptions. You're beginning to put evidence behind each one of them and be able to support your model's predictions, to be able to say, here's why. And with human in the loop, that's critical. If I
Hmm.
can't tell you why it succeeds and especially why it failed, because models don't work, they function. There are going to be times when the model doesn't work. It's wrong. And if there's a person there, they will lose trust unless you can explain why. And as soon as you do that, they treat the model, and this is where human machine teaming comes in. They treat the model more like a team member because everyone messes up. The goal is not perfect. The goal is at least as good as an expert. And when you begin to present that explainability framework and explain this is why, this is why I made this decision, here's why you should trust it. And when it's wrong, you look at it and you say, yeah, I mean, I looked at the same data and I agreed. I was wrong too. And humans begin to trust models at that point
Yeah.
because it's almost like a person. You can almost relate to that and go, yeah, I've done that too myself. Yep. Yeah, don't worry about it. It's okay. And what I'm able to do is say, and because you told me I'm wrong, it's going to get better. You tell me I'm wrong enough, that's
Mhm.
golden information for me. I can now say, because I can explain it, here are the assumptions that were wrong. I can do
Yeah.
more experiments and I can fix this model. And so that's when you talk about where are we ready to go, that's the cycle,
Hmm.
is this concept of human machine teaming. And even with features that get to the customer, having that level of control at the customer level, they are able to trust the model more. I mean, you can look at Photoshop. It's a great example. Until it was really, really accurate, when you would ask it to auto select the outline, select the subject of a picture, when it does that badly, it doesn't tell you why it messed up. And
Yeah.
so, a lot of artists are like, man, this doesn't work. Why? Because it didn't tell them what broke, what messed up. Because artists mess up too. They make mistakes. And if it explained, if it was more human,
Hmm.
they would trust that model at an earlier accuracy and they would be willing to work with it. And that's the power of sort of this human machine teaming framework.
Yeah. Can you tell us more about this human machine teaming framework? Usually, what is like the proportion of human and machine, and how do they exactly work together?
Well, it depends on how good the model is.
Hmm.
That's really where you begin with just hard coded automation, software development, where you ask the expert, how do you know how to do your job? Or how do you know how to do this task that I'm trying to figure out? You hard code that into software. You begin to, the user leverages this, and that's human machine tooling because the machine is not given any sort of autonomy. The person is always in control and they're using the software like a hammer. It makes their job easier, it makes their job more efficient. But now in the back end, I'm gathering data about the workflow. And that can be a user snapping pictures with a camera, and I'm using the camera to make that picture a higher quality image.
Hmm.
I can use feedback. Did they keep that picture? Oh, they deleted it. Okay. So that was not a high quality picture. they deleted it, or they did some editing, some touch up. Now I'm getting even more information. This is what was wrong with the picture. This is like exactly what was wrong with the picture. So how do I improve my machine learning model to make that picture look like they wanted it to in the first place? So I went from this is just software that's doing some sort of hard coded activities to I'm now learning. Can I provide a better picture to the user? And
Mm.
you begin to, like I said, as you establish that trust, they begin to accept the model into their workflow. And they begin, and where you go from human machine tooling to human machine teaming is when the user, when the customer begins to give agency, meaning
Right.
I trust you to make a
Mhm.
decision for me. I
Yeah.
don't want to see the original picture and then the touch up picture and you let me choose. You just give me the touch up picture because
Mhm.
it's that good now.
Yeah. Thanks for sharing that. I think a lot of times we have already this human machine teaming within a data science organization, right? We get feedback from the model and we train a
Mhm.
model, but sometimes we don't think about we need to factor that customer feedback early, so we can learn better because that's eventually the outcome you want to have. But like you mentioned, if your first model is not good enough, you're losing trust from the customer. So your model has to work to some extent, right? It doesn't have to be perfect. So when do you decide what type of internal test you do before you do the initial test with external users?
Like I said, with the human machine tooling, you can give it to users immediately. You can immediately hand this
Mhm.
thing off to them because they're not expecting it to work like machine learning. It's software, and they expect it to work like a software
So
package
some
does.
rule-based solution that you know that works well
Exactly.
enough. Yeah.
Yeah, you've consulted an expert. They've told you here's how it works. Here's how
Mhm.
customers edit or edit photos. And so here's the functionality that you need to give them. And they'll just, they'll press this and it'll do what they want them to. And you press this and it'll do this thing. And so it's very simple functionality. But what I'm
Yeah.
learning is there was something wrong with this image. And that's the data set I'm beginning to gather. And that's what I'm starting to learn with. And
Mm.
that's the process that we rarely do. We dive straight into the model using a data set that is usually highly questionable. I hate to say it that way,
Yeah.
but most of our early data sets are bad.
Yeah.
And we train a model, we don't do any sort of experimental validation with it.
Hmm.
And we just deploy that model. Users play with it a little bit, they really start to hate it, and they abandon it. And they don't
Yeah.
trust you again until you reestablish that trust. So it's far more useful to start with
Hmm.
that logical process, that hard coding, that expert system. Gather the data and then run that model on the side and say, okay, here's the image that we served. We said that they would delete the image and they did. Okay, so that's a low quality image. Why did we think they would delete that image? That's the important part of the explainability to catch on to. Were we right? Did they delete this because it was blurry? Did they delete this because they cut somebody's head off? Did they delete this because there was too much light? And it's all
Yeah.
of these different conditions that their feedback is now informing us about. The
Hmm.
better feedback is when they do editing and they change, they interact with it. And that's a more robust label. And so we can say, if it has this sort of blur to it, can we touch it up to the point where it goes from a photo, the filter says this is the type of photo that gets deleted to this is the type of photo that gets saved. And we can begin to serve that inference and say, if we can get it to this point, they'll keep it. And that's when we begin to give them that model because it is
Right.
now more accurate than the old version, the camera that didn't make any sort of improvements.
Hmm.
And we can give that model to them because it does something the old one doesn't. They delete fewer pictures now. And if they
Right.
genuinely do delete fewer pictures, now we've actually solved a problem. And we can continually improve that model to prevent them from deleting more and more and more pictures and to prevent them from having to do more and more and more editing. And
Hmm.
that's really the handoff is this progression.
Yeah, this sounds like a great example of another topic I talked about in previous episode. We talk about user-centric data science. We talk about
Mhm.
design thinking. So the benefit of thinking, leveraging user is First, they provide additional data points in the beginning, in your exploratory phase, exploratory analysis. And later on, they help you with model explainability. So when we think about model explainability, we think about, Shapley value, feature importance score, kind of just within the algorithm. But, let some people tell you why they're using it or why don't like it, right? Or maybe within your team, if you don't have the access to the user, have you ever used the algorithm, the product you built, right?
Mhm.
Tested with some other colleagues. I think that's another way for you to get feedback to understand the model.
Yeah, it's critical.
Yeah. And then another thing you mentioned, I think is important, design multiple paths to success, because a lot of time data science solution fails, not necessarily because we're not good enough. Sometimes it's just data is not good enough or other unexpected challenges. So do you have a framework? How do you design multiple paths to success?
So there's the business side of that, where what I'm providing users, what I'm providing decision makers, is multiple opportunities. Here is my assessment, and I've got a communications framework. So here's what's going on. That's my descriptive model.
Mm-hmm.
Here's what we think is important about that, and that's a predictive model. And then here's what we think you should do, and that's a prescriptive model.
Mm-hmm.
And so you can give that to a user and allow them to make a decision. And I can give them multiple options. I can say,
Yeah.
here are the options, and here are, and this is a totally different approach to it. So here is what's wrong, and here's why it's broken. What do you think we should do? They can come back with, well, here's my assessment. They are the expert in this case. They're better able to come up with a solution than the model is. And so they look at it and they say, here's our solution. What will happen if I put this into place? And then I can use a prescriptive model and say, this is, if you do this, this is the most likely outcome. And now they have multiple paths, because 3 or 4 people might have 3 or 4 different ideas. Now they can rigorously assess each one and make a decision. That's going to be our primary approach. But we have a secondary, we have a tertiary. So if it seems like this approach is not working, we can immediately switch over to the next best
Mm-hmm.
approach. And you have multiple paths to success. You have metrics along the way that help you decide, should we keep going down this road, or does it look like this was the wrong path and we should now jump to that secondary, that backup? So you can provide data to the business and help them make decisions in that more strategic rather than more tactical, more single plan. And really, the plan, we don't know if it's working until it fails or it
Yeah.
succeeds. We have to
Right.
get all the way to the end in order to figure out if our plan was a good one or not. And
Mm-hmm.
that's the purpose of data, is to give multiple paths to success, but it's also to connect your decision to an outcome. And the sooner you can see, okay, this is working or this is not working, those really switching from lagging to leading indicators of progress, of success. And so that's the business side of it. And when you begin to talk about it from any other side, you're really challenged by the experimental framework. How much access do you have to this system that you want to understand better?
Yeah.
And sometimes you have great access to it, but if it's a customer decision making process, yeah, I can't put anything on your brain. So I don't have the kind of access that I want to when it comes to, why do you like this ad versus that ad? I would love to hook up everyone's brain and figure it out and say, okay, that's the response we're looking for. Yes, this works. And it's because this area in the brain has been activated by the image. I can't do that. And so I
Yeah.
don't have direct access. I have to think up all of these really interesting experiments to
Mm-hmm.
help me do the same thing, to figure out which model should I go with,
Yeah.
which model is the most accurate, which one has discovered something, which assumptions have the highest evidentiary support. But when I talk about that concept graph for the ontology that's being created, those assumptions, I may have a secondary and a tertiary ontology, where if I realize the first one's not accurate, I can go to a second ontology, a second version of the data, a second version of the model, as
Yeah.
sort of a failover, and say, okay, is this going to be better? Oh, this one works better. Okay, let's do that one instead.
Hmm.
And so it's the
Yeah.
same construct, but again, with that, you need more access when you're evaluating ontologies and models to the actual system than you do when you have a person there who's giving, who's evaluating progress, who's evaluating the numbers, who's literally looking at it and part of the process. When you have a
Right.
person, they're almost like a safety net.
Yeah. Yeah, that's a great point. I can share a project I worked on related to video recognition. So we want to detect some actions of soccer players. So because this is a new and challenging problem, and our team split up. I think what you mentioned, a lot of times, if your team is small or just one person, the different paths happen sequentially. But in the beginning, you already thought about it. Maybe on the once you're working on the first option, you can do some ETL data collection for the second option. So you're optimizing your time. And when I was working on a team, we have enough people. So we have two people working on one idea. We're just focusing on where is the entire action, looking at the entire frame, and another person working on some more innovative kind of, maybe this idea doesn't work, but if it works, it could work really well. This person can look at the color of the jersey or trace the location of the football. So we kind of treat this data science project as a portfolio. So how do you manage different portfolio, right? How do you diversify your risk? And eventually, even if one strategy, one method doesn't work, you still have the safety net, like you mentioned. And then maybe you learn something, you can write a paper, use some part of asset, the ETL you created for future projects. So I think this is very important. Don't put all your eggs and time into one basket.
Yeah, the framework that I use is to automate a lot of that. And so when I'm building models at the very beginning, I'm evaluating sometimes dozens, sometimes hundreds, depends on how much compute resource I have access to.
Mm,
And I'm using a model repository. And so the model building, the training, the testing, that part of it's all happening in an automated fashion. And so when you talk about what model do I select, what is my selection criteria, sometimes it's accuracy, but sometimes it's I've got 8 models that are built one way that think this feature, this individual feature is important. And I've got this other model that's actually achieving a higher level of accuracy that thinks a different feature is important.
yeah.
Now I'm learning something. I have you can call it a minority opinion,
Mm,
where the minority opinion's actually performing well
yeah.
on a particular class. It may do really badly on 80% of the cases, but it's actually doing better on 20% than my other models are. Some of the cases
Hmm.
that those models fail, this one succeeds. And now I've learned something.
Yeah.
And so, when you talk about having people working on different approaches, typically I will automate that piece
Hmm.
of it. So I'm not doing, all of that model development again over and over and over
Yeah.
again,
Hmm.
reiterating on it. I've got a repository of different models that I can select from and use and train, and then evaluate across multiple approaches
Mm,
and select the ones that are most promising and really dive into what has this model learned? Why does it think these features are more important than all the rest of the models do?
mm,
What has it figured out? Is that worth experimenting with? Is that worth exploring? Have I learned something, or is that just a coincidence, interesting correlation that has no actual relationship to the problem? It just works because it's lucky. Those are the
yeah.
types of things that I want to be exploring. I don't really care about the model because, like I said, the model is just a hypothesis.
Hmm.
It's really understanding what the model's learned, if anything. I'm not
Yeah.
looking for a different representation of the data because that's just, I mean, who cares? I can do a SQL query and get the same thing as most deep learning models come up with. So it's really understanding what has the model learned, what
Yeah.
new knowledge has the model brought into this particular problem.
Hmm. And you have a repository of models, so it's easy, faster for you to run experiments and test your hypothesis. So
Yep.
how did you build up this repository?
Oh, just every time you build a model, put it in the repo.
Hmm.
It's an incremental process. You build
Yeah.
one, hey, you can do this one again sometime, throw it in the repo. And after about 6 months, you have this ridiculously sized repository that you're always adding. Every project you're adding three, four, five different approaches. And then you have your data engineers and your data curators working from really the front end to look at it and say, I actually have some new interesting features for this particular problem that you might want to evaluate.
Yeah.
And so it's not just me improving and adding new models. It is someone at the front end who understands the problem space, who's beginning to take a look at the ontology itself and say, I've found some data points that might actually be related to your graph. I found some categories of
Mm.
data that may actually be related here. And so why don't you use these and see what you find? And so when you talk about a team, that's why the team structure is really important, because you have this layering. You have people at the data level who are doing, building the pipelines, building the automation that help me stay focused on the experimental side and the evaluation side so that I'm not doing that. And you have people that are curating data sets who are beginning to understand the graph and the relationship underneath, really beginning to map out the assumptions into an ontology and studying that ontology and beginning to recommend, hey, I believe these features of these data points are probably relevant to part of the ontology that you're exploring. Why don't
Hmm.
you try these? And those are going to be inputs to this model repository that I'm just adding to every single time. Why not keep the model? I mean, maybe it works, maybe it doesn't. Who cares? It's
Yeah.
automated. I don't have to worry about it. I'm just looking at what it turns into. Not,
Hmm.
I'm not staring at every single one of these.
Yeah.
So, and that's where I get to focus my time, is on where I can add the highest value. And then
Hmm.
I've got machine learning engineers who are building out the framework for automation. They're
Yeah.
automating an increasing amount of the workflow,
Hmm.
and then ML Ops is at the very end of the process giving me feedback and saying, look, here's what we thought the model would do. And okay, so it does most of that well, but here's kind of a massive problem that's coming up, because they're not just evaluating model performance, they're also looking at input data, and they understand what changes in the data could end up really blowing up that model.
Hmm.
And so they're detecting changes in leading indicators of model failure, so that I get hopefully a day, maybe sometimes two, to actually go in and try to figure out, can I fix this? And if I can't fix it, we put something else in place so that the model doesn't fail. We have a safety net, essentially. When we
Yeah.
detect the condition that we know will cause it to behave erratically, we've got something else
Hmm.
that'll kick in. And,
Yeah.
it prevents me from looking really stupid. And thank you to my data engineers, ML engineers, and ML ops folks that
Yeah.
save me from failure.
Yeah. So it sounds like you have a team that ML engineers and data engineers. They basically help you build a auto ML portfolio. So you
Mhm.
can run different experiments. And then I think that's going to be a shift for data scientists. The value we add is to answer those questions, why the model works this way. Because you don't always have to create a model or solution from scratch anymore. And also, so basically, after the model answer the questions, the post-model process, and also pre-model, like you mentioned, deciding which data set to collect. Is those decisions, those processes, experiments you decide really differentiate you from the rest of the data scientists. So now, if you have a new problem that you don't have any model in your own repository, what is your process? I think we can also talk about your applied ML research methods.
Well, what I've been talking through is really the approach, whether it's a problem I understand or a problem I've
Hmm.
never tried before. When you say I don't have a model for it, let's try them anyway. Okay, none of them worked. Why did they fail? And it's really understanding, in many cases. Obviously, if it's a completely different problem domain or different problem space, I'm not going to have
Yeah.
anything. I'm going to have to build it from
Right.
zero. But for the majority of problems, they're incremental. We've
Mm.
tried something similar, or we've worked in a similar problem space before at this company or at this client. And so we have some frame of reference. If there is absolutely nothing, I mean,
Yeah.
this is brand new, never touched this
Hmm.
domain before. Like I said, the first thing is, let's talk to the experts and let's create their interpretation of the problem space.
Yeah.
What's wrong? What's broken? What doesn't work? Or what do you need automated? What do you
Hmm.
need to work more efficiently? That's the important piece, is working with end users, working with the people that are going to be the ones who touch this, and ask them, treat them like experts. Assume they're always right until I have something that works better. They are smarter than my models ever will be. And so I'm never trying to replace the person. I'm just trying to improve them. And if you look at Copilot, that's why it's such an amazing feature. And this is something that the majority of large tech CEOs are starting to talk about, is the augmentation, where I give you a tool. It doesn't do everything for you. It just works with you to make you a little bit more efficient. It does something that normally takes you a long time. Now it takes you less time. And it's just that little incremental change. But you look at how
Hmm.
useful Copilot is, and it's fairly, it's autocomplete. It just
Yeah.
autocomplete,
For your
at
code.
another
Yeah.
level forward. But it's so useful.
Hmm.
And the amount of data that they're gathering about which suggestions are accepted, which suggestions are rejected, that's how you incrementally improve. So you start
Hmm.
out with something like autocomplete. You now look at the problem from, okay, I now understand the problem a little bit better because I've watched autocomplete work, and I'm starting to gather some data from autocomplete. Now I'm going to augment that data set with all of this data from GitHub, all of these open source repositories, where I'm going to begin to augment this human generated data, where they're giving me feedback on whether the suggestion was right or wrong, with, here is now this massive corpus, and I'm going to use a large scale language model, and I'm going to now add functionality. Now it's not just autocomplete, with maybe here's a couple of snippets of code. Now here's an entire code segment.
Yeah.
And so you see that incremental improvement. And that's the approach that I'll take, is
Hmm.
I need someone to generate data. I need access to the system so I can perform experiments. And the easiest way to get that is to just put software in and gather data about how the person interacts with the software. How do they
Yeah.
use it? Now I have data about their workflow. And as
Hmm.
soon as I have that, that's golden. If there's
Yeah.
not that much access, where I don't have a person, I don't have a user, I have to
Hmm.
do observational studies. I have to gather data that's just kind of data gathering in the blind. I don't really know anything about the solution space. I have a vague understanding of the problem space from experts. And now I need to fill in the gap. And I'm going to do that by gathering a whole bunch of data, doing observational studies, building models. And then I have to be creative about figuring out how to experiment. How do I get access to this system? What parts of the system do I have access to? What parts don't I have? And then I have to get creative. I mean, how do I look at this system? And the more I understand it, the more you understand that graph, and how, the interconnectedness of data points and interconnectedness conceptually. You have that domain knowledge and that expert knowledge. You can make some assumptions. You can say, okay, so I want to observe this. I can't. What that's related can I observe? What that
Hmm.
touches this, what that influences this, or this
Right.
influences, can I get access to? And can I do an experiment on this part that I have access to that will give me new knowledge about the thing I want to know?
Right.
And so that's the process,
Yeah.
and it's
You can find a proxy.
right. Yeah, exactly.
Yeah. Thanks for sharing that. And you worked with customers a lot. And what are some challenges when you work with customers? For example, if they don't like what you provide, or they don't know what they need. I mean, those are different type of problem. I'm curious, what are some common challenges you face?
I think the biggest one is that people have been told deep learning works, and it doesn't. Deep learning is the beginning of the process, not the end of it. And I think that's the biggest problem, is they think that all they have to do is deep learning, and that's the end of the process. And so I have to work with organizations to decouple them from the technology and say,
Mm,
look, don't worry about the technology. Stop. I'm going to give you a process. We give you a framework, and your job is just live in that framework. Don't worry about the technology. That's complexity you shouldn't care about, and you shouldn't have to get dragged into. And so I frame it that way. And I say, look, you're getting dragged into this technology. Don't
mhm.
worry about it. I'll handle that. That's our job. You never have to worry about technology again. And that's why it's important to replace model metrics with business metrics. Because as soon as you do that, senior leadership doesn't care what's behind the scenes. And they go from really questioning things to, this is the thing I care about. The thing I care about is getting better. I don't care how it's getting better. All I care about is the thing I care about is getting better. And it's that process of building trust from there. And as soon as you can get users to no longer care about the technology,
Hmm.
you just give them a solution. Customers, who cares if it uses AI? Who cares? I mean,
Yeah.
there could be a monkey behind the scenes,
Hmm.
literally pulling levers. What do you care? If it does what you need it to do,
Yeah.
hey, it's monkey learning. Who cares? And
Hmm.
as soon as I get people to the point where all they want's a solution, who cares what the technology is? Let's use the right technology to solve this problem rather than deep learning works. That's powerful. That's the switch for me. And when I look at every customer problem that I encounter, it's always a strategy problem. And as soon as I can get them back to caring about either how this impacts their job or push senior leadership back into managing value creation, as soon as I can do those, everything gets so much easier
Yeah.
because they're giving me the feedback I need. This works, this doesn't work. That's all I need. Who cares about the technology? I will make it work. That's my job. That's all I do.
Yeah.
I'll make it
Yeah.
work.
Exactly. Sometimes customer come in with some idea, with some technology, or maybe they have data scientists work on similar solution, and they want you to fix that or make that better. So
Yep.
what we really need to do is to take a step back. Okay, what do you really want to achieve on a business level, and speak their language? Okay, we want to achieve this business goal on a very high level, and then now
Mhm.
don't worry what I'm going to do. Maybe all you need is a dashboard, right? And then if deep learning really need to solve a problem, we'll revisit that. But we don't have to be so attached to a specific problem. And now I think you talked a lot about trust to convince the customers, the business leader to relax on the technology. They have to trust you. So how do you earn that trust, especially in the beginning? They're very attached to their current solution.
I start with the current solution. And that's the approach I always take is you're an expert. You know how to do your job better than any
Hmm.
model I can create. And that's the truth. I got nothing that's a person. I don't. I have ways to improve you. I have
Yeah.
ways to make you more efficient. I have ways to make your decisions better. I have ways to make your workflow simpler, make you hate your job less. I have ways to do things that you care about. But you're always going to be smarter than my model. I mean, I'm not giving you real AI. That's not, I can't, I don't have that. I'm sorry. I don't sell that. And so, and that's, I think the problem that we really create for ourselves is we say, I'm going to give you this thing that's smarter than you. And we're not. We got to stop saying that. It's not smarter than people. People are really smart. Can they be wrong? Of course they can. And more times than not, we are. When it comes to business, businesses are all about learning and iteration. And so when you talk about this as learning and iteration, people begin to get it. And when it comes to trusting me, if I don't trust them first, if my first solution is you're wrong,
Mm.
there's no way I'm getting trust. Come
Yeah.
on. So I have to come into them and say, look, you're the expert. You have expert knowledge. And I explain to them, look, that's critical for causal thinking. That's critical for data science and machine learning. We start with expert knowledge. There are assumptions baked into expert knowledge, but you're always going to be smarter than my model. I'm just going to use my approaches to validate or refute all of these assumptions, and I'll come back to you when I have a better one. Just because I refute an assumption doesn't mean I come back to you. Because what am I going to replace it with? You're wrong is not an answer. You're wrong is not a solution. And that's where I think a lot of us lose trust as we come to people and we say, look, you're wrong, they say, okay, so what? And oh, well, I got this dashboard. It's like, yeah, but is that dashboard really better, or is it just
Yeah.
different?
Yeah.
Because I have to. It's not just disproving an assumption and replacing it with maybe better. It's disproving an assumption and validating a different one to replace it. And until
Yeah.
I do that, I, I'm gonna sit. I'm gonna sit in the back and just say nothing. Yeah, you're
Yeah.
wrong, but who cares? I'm not right either,
Yeah.
and
That's
what
such
you're
a great
doing is
point.
working.
Yeah.
So I'm not going to break what's working. Yes, I know it's wrong. I got to fix it. And that's trust. I bring you something better
Hmm.
and I give you frameworks. That's the other piece of trust is I give you frameworks to manage value creation, or I give you frameworks to evaluate my solution and understand how I'm continuously making it better for you. And if I don't give you those frameworks, you have no way of giving me the kind of feedback that I need. And you have no connection to the process of making something better. You're not going to trust something that you don't understand your role in improving. And if I give you this thing that doesn't work, you're not going to use it unless I tell you, look, here's where it's going to work. Here's where we don't know if it's going to work or not. So if you want to use it over there, we would love the feedback, but we're not real sure what'll happen. But here, we've been rigorous, we've validated it, this will work.
Yeah.
And when you can trust and use that framework, everything gets so much easier.
Yeah. It's easy to point fingers to tell people something doesn't work, but it's hard to come up with a solution. And I think you also had a great point. Trust is mutual. A lot of time data science come into the meeting, they have this attitude, you're business leader, you don't know how to code, I know better than you. So people can sense that kind of arrogancy. And then when you talk to people like that, they already don't trust you. So I think it's very important that to trust them to really listen. What's their current solution? It's they've been using it for a while. There has to be some value in it. Do you really take the time to learn the current solution and see whether you can make it better? And once you have a system you can provide, and now you can tell them, hey, maybe you can consider my solution. I think that's a really great solution. It starts from respect. So, what are some other challenges you have working with customers?
The challenge is really what I've defined is that there's an expectation and there is a precedent that always has to be overcome. And the first one that I address is this is not just a technology thing, this is a business thing.
Yeah.
And this isn't a we're done tomorrow thing. This is a we are never done thing. Transformation is a continuous process. It's not a one time thing.
Mm-hmm.
You'll be transforming forever. You will be innovating forever. It never ends. You're going to be doing this. You're going to be doing this with quantum here pretty soon.
Yeah.
It's never ending. It's going to just
Yeah.
keep going. So you have to build these frameworks. And that's the most important piece. Even if you mess up analytics, who cares? Data science is right on the other end of it. Even if you mess up data science, who cares? Decentralized is on the other end of it. And we've got platform business models on the other end of that. And we got, and there's all of these waves of disruption that are coming. All that matters now is you put the framework in place so that you can monetize every single one of these waves from here until I don't know, time travel. I don't know what 50 years from now even looks like,
Mm-hmm.
but whatever that is, it's not about the technology you're using today. I mean, the technology you're using today will be obsolete in 5 years.
Mm.
It is putting in place an organization that builds for today, builds for revenue right now, builds for near term opportunities. But everything you build today is built to still work, to still function, to still support what's going to come in 5 years from now. And so you're not, innovating like a futurist. You're just building stuff that will be as cheap as possible to continue to extend, that will be as inexpensive as possible to continue that transformation process and move to that next wave. And I think that's the misconception is like it's all about data. Well, okay, today, sure. But what about next month? I don't know. No idea. When's the metaverse happening? But we're going to build today so that whenever that next thing shows up,
Hmm.
we have an idea, we have a framework, we know what is going to be necessary in order to make those next jumps and monetize those next things. We're just going to make sure that every decision we make today has an eye towards, and it will change later. So this has to be really easy to fit into that new paradigm.
Yeah.
And that's the mistake that previous transformations have made, is they've gotten
Mm.
fixated on that one technology. And it's like, who cares? Yeah, data science this week. Who next week? I mean, who cares? Who cares what the
Yeah.
technology is?
The thing is, it's hard to predict when is the new paradigm happen. So how do you make your solution flexible?
Well, I know that at some point the business is going to migrate from its current business model to a platform business model, where what automation does for the business is it moves as much complexity to that core as possible. It automates as much of that complexity as the technology for automation supports at that moment, whether that's software logic or super duper advanced deepish reinforcement esque symbolic learning massive approach, whatever you want to call it, but
Yeah.
it's going to exist and live on the platform.
Yeah.
The platform is going to allow you to provide access to an ecosystem. We know
Right.
that's where we're going. And so everything we build now just supports that. Yeah, I don't care what is on the platform, but the
Mm.
platform has to extend to support a ton of iterations. It can't be this monolithic thing that if this technology changes, we're out of luck. We got to forklift it. So it
Right.
can't be like that. It has to be
Hmm.
built so that something completely foreign can just be dropped in.
Right.
And that's great thing about mesh, great thing about services. Great, all of these things, especially cloud, all of this supports whatever. Cloud doesn't care. As long as you build apps for, you architect them to be scalable. You architect them to handle new platforms. Then who cares? It doesn't matter.
Yeah. Right.
And that's really don't fall in love with the technology because it's
Hmm.
gone. In 5 years, it probably won't be here. Don't fall in love with an approach because in 5 years, there'll be a better one. Don't fall in love with any of this stuff.
Yeah.
Build today as if in 5 years, this will be obsolete. And so it has to
Hmm.
be as cheap as possible to
Yeah.
take this thing out and put something else in its place.
Yeah. So data science or your data solution is only part of the entire kind of engineering
Mhm.
system, and even engineering system can change. So then some data scientists, especially when they just got into data science, they have this anxiety. Oh, I don't know everything. I'm still learning, data science, statistical models, and also the engineering side. So what skill set should I prioritize? I saw you wrote a lot of great LinkedIn posts about different type of data science careers, the researcher, the builder, a leader. And so from a personal growth perspective and also from a team building perspective, what do you think is the modern kind of data science team and career path?
So there isn't a career path yet that's defined by businesses. Businesses have no idea what to do with you after you get to the principal level. They're just
Mhm.
going to give you another cool, distinguished
Yeah.
staff. Uh, Super cool data science. Yes, you're a super cool data scientist. You're, they're just going to throw more titles and more cash
Right.
at you.
Yeah.
There's no career path. They have no idea. Because think about it. How long have most businesses had a data scientist? What, 5 years, 10 years tops? So they've never had to do a career path for a data scientist because the average tenure for a data scientist is less than 3 years. They only usually have to promote them once or twice and then they're gone. And so there's no such thing as a career path that a business is going to give you. You have to make your own, which is crazy. You have to figure out your learning path because you're the one who understands the technology better than anyone else does. I say I've been doing data science for 10 years and I'm a grandfather, which is ridiculous. 10 years of experience is
Yeah.
like, I just hit senior.
Hmm.
Like in any other field, I would just be a senior data scientist. And I'm really lucky because I have 25, over 20. Oh, God, I'm old. I have over 25 years. of technology experience. And so I kind of understand from that old engineering paradigm, software development. I understand what it takes to really become senior, to really become someone who is proficient at this craft. And it takes so much more time. We have senior software developers who are at 10 years in their career. We have senior data scientists who've been doing it for 3 years. Like they graduated from college 3 years ago. They're a senior
Yeah.
data scientist now. And there's no one's done in this field. No one's baked.
Right.
You talk to Jan LeCun just came out with a post today where he said, "Yeah, a lot of that stuff about deep learning that I said. Well, I got a better approach now. Like none of us have this figured out.
Mhm.
All of us are continuing to improve on the thing that we did yesterday." And that's
Yeah.
why I say, your career is really like a business. You need strategy. You need multiple paths to
Mhm.
success.
Yeah.
You need to not fall in love with the technology because I coded models in C and Java.
Mm.
Right now, that sounds like I could get into a fight at certain companies if I said I code models in C or Java. That
Yeah.
could start an argument in some companies because there's better alternatives now, except for some things. And then you have to use this other tech. It's just like don't fall in love with anything because in 5 years you won't be using that. They'll be like, you know, one Python or something like that, where somebody came up with it. It will be something different. And so there's no career path
Mhm.
other than the one you create for yourself. There are no opportunities in data science except for the ones you create yourself.
Yeah.
There isn't a learning path except for the one that focuses on value. So if I'm going to
Mhm.
tell like an aspiring data scientist, what do you start with? Figure out how to create value for a company
Yeah.
and then build technology knowledge on how do
Mhm.
I do that better? How do I continually improve that? Is there a better way of delivering that value? Well, that's what I should learn. I should learn that. And if
Yeah.
it's Web 8.0 or deep learning, or it doesn't matter. Just figure out how to deliver value and then build your technical capabilities around that.
Mhm. And for someone who's more interested in building software, like a builder, or someone who's more interested in the algorithm or researcher, what do you recommend?
It's the same story. I mean, everybody that works in a business is accountable for value. So if you want to become a researcher, okay, well, what value do you think a researcher delivers? And that's where you really get into what do you actually want to do? Because
Mm.
researcher is this cool title, but what does a researcher do? Well, you tell me. How are you telling me you want to be something and now you're asking me what that something is? So that's and that's why I say start with value. What value do you want to create for a business? What value do you
Mhm.
want to create? What problems do you want to solve?
Yeah.
As soon as you know that, then start looking at, okay, so this is the problem I want to solve. Who do you want to solve it for? What
Mm.
industries, what domains, what use cases do you want to solve that problem for? Okay, now you're even more focused in what technologies do people in that domain, in that functional area like HR or marketing or whatever, or in that particular problem space, that use case, what technologies do people use to solve that problem now? What technologies are they thinking about? What
Mhm.
approaches are they thinking about using?
Right.
What capabilities do you need to be able to apply those to solve the problem? And if you work backwards that way, you get away from job title
Mhm.
and get to what actually matters to you. What problems are you passionate about? What customers do you enjoy serving? What kind of value do you enjoy producing? What makes you happy? I mean,
Yeah.
don't go home miserable. What makes you happy at the end of the day?
Yeah, that's important. And from a hiring perspective, so if you are going to build a data science team, what are the different type of data professionals you try to hire?
Well, it depends on the company. Every business needs different, and so that's what I have to
Yeah.
start with. Is I'll build out the strategy, and then I'll go from there to building out a product roadmap, build out some basic workflows based on what it would take in order to build those products. What am I going to have to actually do? When do each one of these products come into play? Because that's the roadmap piece of it.
Hmm.
So, when does this talent need to be in place in order to achieve and execute on the roadmap? what transformations need to happen in the business in step at the same time as I'm hiring people. Can that happen? I mean, is any of this stuff feasible from a timeline perspective? And
Yeah.
that's what's really important is a lot of times companies will hire a ton of people and not be ready to use them. So if you don't really have rigorous data gathering, why hire a data scientist? You can't use one yet. If
Mm,
there's no good data to create a model with, why are you hiring a data
yeah.
scientist? You're not ready. If you need the business units that are gathering data to do some sort of transformation, if they need new capabilities, if they need new software, new platforms, just to gather data better, why would you hire someone until all of that's put in place? And so that's I approach it really pragmatically is when can we actually use these people?
Yeah.
What capabilities do we need? If we have great high quality data, we can go straight to hiring a data scientist. Do we need a data engineer? No, we got great data.
Mhm.
Hire the data scientist first because we're going to be able to take advantage of their capabilities from day one.
Yeah.
But the majority of businesses don't. Garbage is the data is terrible. So hire a couple of data engineers and some analysts. You can get some very quick wins from the analysts who are really good at analyzing and getting some insights out of
Mhm.
just terrible data. And they're going to do the early groundwork for you. Data
Yeah.
engineers and analysts are going to work together. They're going to clean data to the point where it's useful for descriptive modeling. Then you can hire a data scientist. And that data scientist is probably going to be somebody who's going to have some engineering capabilities because we don't have an ML engineer yet. And so that data scientist is not so much research focused as they are engineering and architecturally focused. And then once we get to the point where we're doing more projects, we need to scale and do more projects at a time. We've built up enough trust. We're delivering enough value that we can justify adding to the team, asking for a little bit of that return that we've been giving back to the company, those cost savings and that revenue. Can I add 20% of that to hire somebody else? Now you have this, and you talk about building trust. Now you can look at what it is. What do we need? Do we need more data engineers? Do we need another data scientist? Is it time to bring in somebody for ML ops?
Yeah.
Is it, and so it's very pragmatic. You can look at the needs there, and it's a transformation roadmap and timeline. It's an organizational build out plan. It's really just pragmatic. It's what can we do? How fast do we need to do the next step in maturity? And again, it's really building today. Even if you're not going for like you're a level -5 maturity, who cares? Well,
Mhm.
what do you need to be in order to be competitive and to deliver value? What do you need to be? Okay, so you need to be at a 1. All right, when do you need to be there by? It's really just pragmatic.
Yeah.
Do you need to be tomorrow? Probably not. Maybe. Did Google just show up and try to compete with you? No. Okay. Well, who are you competing with? Are you competing with a whole
Yeah.
bunch of legacy businesses? Well, you don't need to be,
Right.
Google tomorrow then. You could just if you can get models into production, you will probably dwarf their capabilities if you're dealing with, these old legacy companies.
Yeah. So it's really case by case, depends
Yep.
on also the stage of the company.
Yeah.
And yeah, and for a data scientist or ML engineer in an organization, and they already have some experiences, and now they want to grow to a tech lead, maybe down the line become a manager. What are some skills or some type of mindset you think they need to adapt to make that shift?
Leadership is a capability set in and of itself. So to go from I am technically the smartest person on earth or on this team, therefore everyone follows me, listens to me, comes to me for advice,
Yeah.
to I am now going to lead people who are smarter than I am, who know things I don't. You hear your source of authority. It's moved from I am the smartest person in the room to uh to what? That's leadership. That's making the transition from someone who's an individual contributor to someone who's a leader. You
Mm,
now have to figure out what are your sources of authority? What else am I going to replace my knowledge with? I'm no longer the smartest person in the room. Why? I'm going to
right.
hire people that are smarter than me. And so now you have to make that transition and you have to decide on a new source of authority. That takes mentorship. You have to have someone who is a leader, spend some time helping you develop your new sources of authority. You have to have someone who is a high quality mentor in the leadership structure, in the organizational structure, spend some time with you. And that's what we don't do with data science leaders. We don't have a director or a VP say you want to go into leadership. Awesome. we're going to spend an hour a week hanging out. We're just going to go to lunch or something. And I'm going to talk to you about what it takes. And we're going to walk through what it takes every week, 1 hour a week for the next year. I'm going to get you there so that when I promote you, you're ready to at least embrace the role and succeed, not rely on a source of authority that just doesn't play anymore.
Yeah.
And we need to do that more. So if you're thinking about going into that next level position, find somebody in the organization and say, look, dear leader, I need you to help me understand what it means to lead people.
Yeah.
But I don't just need a manager telling me how to lead. I need a leader who knows how to mentor other leaders. Managers don't know how to
Mhm.
do that yet. So you have to find someone who's done that, and that's usually director or VP level. So what
Right.
most companies don't understand is just because you are a leader doesn't mean you've learned to mentor other leaders. You don't learn that until you're usually 2 steps above a manager.
Right. And I think for engineers or product managers, they usually report to a manager that in their same job family. And for data scientists, they're in an interesting situation. So a lot of data scientists, they're only data scientists on the team. They report to a engineering manager, report to a product manager or a marketing manager. So sometimes their manager don't really understand how to grow their career. So do you have any advice when someone's in this type of situation?
So a leader can mentor you to be a great leader no matter what they do. If you are a great sales leader, you understand leadership because leadership is a totally separate skill from the technical side. And so, as a leader in data science, in machine learning, in strategy, I can mentor any leader because I understand the separation.
Mm-hmm.
Leadership is a completely different capability. Just like a software developer who does, pick your particular domain, can teach that software language to someone that's going to do something completely different. They won't have the specifics to say, this is how you apply it to your domain. So I won't be able to tell you, this is how you lead your domain. I will teach you how to lead. And it's
Yeah.
those things that you begin to synthesize and generalize to
Mm-hmm.
your role. It's really hard to be led as a data scientist by a non data scientist, but the two are different problems. Being
Yeah.
led by that person or being mentored into a leadership role, two
Mm-hmm.
different things. So
Yeah.
they will be more than capable. I mean, if you work for like the chief marketing officer, they'll be able to mentor you. They should be able to mentor you to become an effective leader. They probably won't to become an effective data scientist.
Yeah.
And the two are completely different.
Right. And you need to find those type of mentorship in other places. Yeah. So you have been doing, data science, AI strategy for so long, like you mentioned, you are a data science grandfather now. So
Yes, I
what
got the
type
gray
of
hairs.
so what type of shift have you observed from the beginning, from 2012 to now 2022?
I didn't even know it was called data science in 2012. And I'm not
Data
even joking about that.
analyst?
We didn't know. We had no idea. There were a bunch of us. I mean, outside of San Francisco and New York, I would say, none of us had any idea what a data scientist was. We didn't think
Yeah.
that's what we did. There were, I can't even tell you how many different names were made up for
Hmm.
data scientists
Yeah.
at different companies, different organizations, different consulting houses
Hmm.
before finally somebody just said, look, no, it's called data scientist. We got to stop calling it other stuff or we're going to confuse people. We didn't even know what it was. And we went from, we're going to use data in cool ways, which was really the BI analytics paradigm. We're going to use it in cool ways to, we have to get into production. Like it actually has to deliver value. And that was 2015. It has to
Hmm.
be in production. It has to deliver value. And we went from it has to be in production and deliver value to, okay, and it has to work reliably. And that was 2017, 2018, when ML ops started to become more popular and more accepted. And now we're really at the point where we are redefining reliability. And we're saying it has to work better than stuff has in the past because this is different. we're now differentiating from other technologies. And what's really fascinating is when you begin to talk about platforms, whether it's a centralized platform like Meta or like Disney has,
Hmm.
or a decentralized platform like Web 3.0 is trying to figure out what that looks like.
Right.
You need machine learning in the center. Otherwise, it doesn't work. And
Hmm.
so now we are an enabling technology. This is like cloud, where cloud went from, yeah, it's kind of cool to you can't do machine learning without cloud. Like it just doesn't work that well. It doesn't scale correctly. It
Right.
won't handle the type of use cases that we really needed to. So now
Hmm.
cloud is a supporting technology that without cloud, we wouldn't have machine learning. We wouldn't have deep learning. We wouldn't have all of these large scale language models. We didn't have any of this stuff.
Yeah.
I can tell you back in the 90s what we had to do in order to get machine learning to work. And it was janky. It was terrible. We had to create like these really ugly, horrible clouds. And so without that, machine learning doesn't work. And now we as a technology, without us, platforms don't work. This whole concept of the platform business model doesn't work. Scale doesn't work. All of these different use cases. And when we get to quantum computing doesn't work without machine learning.
Hmm.
Quantum sensing, no chance. Unless we get machine learning to work really well, none of this stuff is going to be feasible. And so every technology wave that comes after this is going to be built on machine learning. And that's what I'm watching happening right now. And it's kind of, this is the coolest time, really, for data
Yeah.
science and machine learning, because we've gone from it's got to work with a high level of reliability to it's really got to work because now
Hmm.
we're building stuff on top of it.
Right.
And just think like if Amazon was crashing, every couple of weeks, would that be okay? No. They would, oh God, no. We'd be back to Twitter's fail whale, where that would be, every couple of weeks. Maybe I'm
Yeah.
too old. Maybe I'm the only one who remembers the fail whale. But yeah, Twitter used to crash a lot,
Hmm.
and you would get the fail whale.
Yeah.
And like it's the same thing. People didn't really adopt it because it didn't really work all the time. And
Right.
machine learning, nobody will adopt it if it keeps, if it keeps showing people the machine learning fail whale. It's just not gonna, it's not gonna work.
Right. So, what does this shift mean for data scientists today?
It means you got to go towards causal. That's the only way to really explain it. You have to go towards scientific methodologies, study design, building actual experiments, understanding the fundamentals of causal machine learning, where you have causal inference on one side and you have machine learning supporting it. And so you have
Hmm.
machine learning feeding into causal methods, and then you use machine learning to validate because you don't, like I was said with the experimentation, you never get access to the system in the way that you need it. So you have to get really creative. Your experiments are not scientifically rigorous. And so you need something on the other end to kind of make up for the fact that, yeah, if I tried to publish that in a scientific journal, I would get destroyed. But in a business setting, it doesn't have to be perfect. We have a different level of functional that as long as we validated it and we have met reliability requirements,
Hmm.
you can kind of bend some rules. And that's really what you're learning how to do is understanding machine learning, deep learning, causal methods, and then the combination, that overlap of the two. And so if you want to have a role in applied machine learning and applied research, those are the capabilities to focus on. And when you begin to look at data engineering, you're going more towards curation and the creation of ontologies. If you look at the other end, machine learning engineering, you are handling things with increasing complexity and increasing scale. And so you are really going more into the architectural side of
Yeah.
software development and software engineering than you are, the more traditional applications engineering. You're really now going towards high level architecture, solving problems at scale rather than just solving kind of automation type, basic support type things. And
Right.
ML ops is emerging as a multidisciplinary role where
Mm.
it's almost like a quality assurance
Oh,
data
interesting.
scientist.
Yeah.
It's
Yeah.
like I'm kind of throwing two words together and hoping that it makes sense, but
Hmm.
it's almost like a
Yeah, it's
quality
interesting.
assurance
I
data
just realized
scientist.
there's no QA in the data science team, but that's actually what we do, the testing, ML ops
Yep.
you mentioned. Yeah, it makes sense.
Yeah, and what's kind of scary with ML ops the way it is right now is we're testing in production, and that's not good. It's really not good. We shouldn't be doing that. We shouldn't put models into production before we've done the QA. That that's never worked well. So, the concept of running models in shadow, that's awesome.
Right. Yeah.
Doing more of a rigorous validation of the experimental process,
Hmm.
which is a research function, that's also a QA, like a
Hmm.
model and research QA role.
Yeah.
We need that. We need, I mean, we need data quality assurance. We need so
Yeah.
much. Oh, there's so much left.
I think MLOps just another word for QA, but sounds more exciting.
Right? Yeah, ML
Yeah.
ops is QA by a different name, and they get paid better, so that's good too.
Yeah. And you have a background in QA, so that also give you an edge when you start to think about this problem, right? Like what are some key principles in QA that you later adopt in ML ops?
I don't think they're equivalent. From a functional standpoint, you could
Hmm.
definitely say that functional testing, regression testing, all of that stuff,
Yeah.
yeah, it applies, but it doesn't mean the same thing to a model as it does to software. And I
Hmm.
make the distinction: software works. I could give you a specification, you could test to that specification.
Yeah.
How would you create test cases for Alexa? You
Mm.
can't. It has too much functionality. There's no way to QA using that traditional paradigm. You can't write test cases. I mean, how do you write a test case for somebody that asks, show me the nearest jelly beans?
Right.
I
But
mean,
you have to, when you factor the user into the function, it's more complicated.
yeah, that's why I say it's human machine teaming now.
Yeah.
And the quality assurance function changes completely to we are
Mm.
validating reliability requirements, not functional requirements. Those are two completely different paradigms. And so when you think about it from a traditional quality assurance standpoint, there's almost no overlap aside from it actually has to work. Like the user has to enjoy it. It has to be usable. So when you talk about design thinking, user centric design, those definitely cross over. But when you talk about the paradigm for quality assurance outside of automation, unit testing, those frameworks play, they just look different when you try to translate them to models and validating model functionality. And you begin to get into adversarial machine learning because we have a completely different problem when it comes to securing a model. And securing a model is really revealing also some of the functional failures of a model because
Yeah.
those are the exploits. And there's this interesting crossover between if it isn't secure, it hasn't been fully QA'd.
Yeah.
And during the QA process, you're probably going to find security vulnerabilities too. So there's this interesting, QA and security for models are going to overlap.
Yeah. Yeah. Thanks for sharing that. And I also something I observed. So I think I started working around 2014, 15. My title was either statistician or data analyst or BI analyst. And now those titles still exist, but some shift I see more are there start to have new titles like analytics engineer, even data science engineer. I think in the future, there will be a higher bar for science and analytics. So the science and analytics, even if you know deep learning, it's already implied in those roles. But everybody's going to be a engineer. You're going to be a data science engineer, analytics engineer, deep learning engineer. I think the focus is not like we have less focus on the science, but because everybody now know more science, we really need to think about building a solution that actually useful, drive value for the business, like you mentioned. And we'll see what happens in 5 years.
Yeah, I mean, I don't think people understand science enough. I don't think data scientists understand science well enough. That's where I see us as a field moving forward is
Hmm.
we begin to bring in people from different hard sciences disciplines and let them teach us the
Yeah.
science side.
Hmm.
Really let them teach us the research piece of it and the
Right.
scientific methodology, the study design, research design
Hmm.
methodology. I think that's when we become a much more advanced, much more capable field.
Hmm. What other some areas do you think data scientists can learn more from?
Well, obviously physics.
Hmm.
Obviously physics. Learn everything from a physicist. But if you look at the way that biologists work, the concept of an ontology has really been pushed forward by fields that are associated with biology. That they have a better understanding of ontologies than I think any other field outside of maybe linguistics. And you bring in scientists that are working in neuroscience. You bring those into the field, and we can learn a
Yeah.
lot from them. You bring people that are working in behavioral economics. You bring people in who are working just pure chemistry, pure
Hmm.
genetics. They have to reach a higher bar before they can publish anything.
Yeah.
And we're never going to be that rigorous because we have ways to cheat.
Hmm.
And the only times you really understand when you can cheat and get away with it and when you can't, when you can cheat and you'll get caught for it, or when you have that stronger understanding of the science side of the field. When you understand research and what you can say, what you can support, and what you can't. Because it doesn't have to be perfect to get into production. I mean, look at software. We have never deployed perfect software, well, except for me. I've deployed my software always works, but everyone else aside from me has deployed software with bugs in it,
Hmm.
and we accept that. It's the same thing with data science and machine learning. We're
Yeah.
going to put models with flaws into production, but it's important to understand what those flaws are and have safety nets so that
Hmm.
people don't see the problems. So
Yeah.
those are, those are where I'd say I think we are going, and where I think we can get a lot of benefit from talking with hard sciences fields.
Hmm. Yeah, and I do see a lot of people come from the hard science field and transition into data science, and previously had guests in neuroscience and physics.
Hmm.
And although a lot of things they have to learn that's new, but a lot of, like you mentioned, the research
Hmm.
methodology, or they have to learn like very hardcore math to really help them in their career in data science. So for example, for you, how do you learn new domain knowledge, new disciplines, or like new tech?
I run into it for a reason, and I think that's the really important thing to point out. Is I'm building something, and all of my tricks don't work, so now I got to find some new tricks. And that's where I ran into causal when I started following causal methods in 2015, 2016.
Yeah.
And it's because I got to the point where everything I had sort of leveled out. It
Hmm.
only got to a certain level of accuracy, reliability, functionality. I needed new tools. So I
Yeah.
started looking around and looked for smart people. Who are the people that are smart in this field? Who's applying it? How is it being applied?
Hmm.
Does it work? And if you follow that applied framework, you begin to figure out what you need to learn. Instead of learning the entire field, you really just learn what works. What are
Yeah.
people using? What actually is functional? Because
Hmm.
you can, I mean, especially with the math side, you can get a PhD in math and still not understand data science. So you can go down that rabbit hole all the way and understand advanced math. But if you don't have anything to use it for, why learn it? That's why I say if I'm talking to students, figure out what problems you want to solve and how people are solving them now, what challenges are open, and how people are trying to address those open challenges. And everything those people are doing and publishing and writing about and building, that's what you have to learn.
Yeah.
That's your body of knowledge. And they'll tell you what you have to learn. And if you ask, this is the great thing about our community, we're all so accessible. If you don't understand something, you can just say, hey, I didn't understand that. How'd you learn it? And we'll say, oh, check out this book. Like
Mhm.
I can literally reach over and grab books from my bookshelf when people ask me that. Well, how'd you
Yeah.
learn, this or that? Oh, I got this book over here. Or, oh, just follow this person on LinkedIn or Twitter. They got like a YouTube channel. Check this YouTube channel out. They explain
Hmm.
everything. That's the great thing about what's happening now is you don't have to learn in college anymore. And it's almost easier because every time you run into a problem, now you've got to figure it out. But how many times do you really run into a problem that no one has solved before?
Yeah. Yeah.
Not much. So you just figure out who solved that problem and figure out what they did.
Right.
And whatever you don't understand, learn that.
Hmm. Yeah. The internet is the best university these days. And so, for causal inference, what are some resources you recommend to the audience?
Book of Why, follow GD Pearl on
Hmm.
Twitter. He will, over the course of about 6 months, educate you into some of the really nuanced paths that you end up following. Causal inference, the mixtape. Hold on, let me find the author.
Hmm. Yeah, we can add it
Scott
in the.
Cunningham. Yeah, Scott Cunningham. Sorry, no, I wasn't kidding when I said the books right there.
Yeah.
Yeah, Scott Cunningham. He's got a great book, just soup to nuts. Really does a great job of explaining it. Um, Microsoft and Amazon both have exceptional work that they're doing, and they've got a new library that they're collaborating on called
Hmm.
PyY, which is an iterative improvement on Microsoft's DoY with Amazon's framework now being integrated into it. Netflix has a causal lab that's doing a lot of really interesting work. Lyft, I think it's Lyft. Lyft is also working in that direction. It's either Lyft or DoorDash. DoorDash, yeah, it's DoorDash, not Lyft. Sorry. DoorDash is doing some really interesting work in that direction as well. There, if you want to understand the applied side, those would be the ones that I would look at. IBM's got some interesting work that they're doing in the causal space. What's really fascinating is it seems like anybody who works with cloud also has done a lot of work with causal. I don't know if there's a correlation there, but it feels like there is. And so you
Yeah.
can follow anyone that's had problems at scale.
Hmm.
It ends up working with causal methodologies. And there's a lot of work being done to integrate causal and machine learning together. And that's what you can learn from companies like Amazon and Microsoft. Netflix is doing the work there too.
Yeah, yeah. I have observed that I think those cloud provider, a lot of them hired a lot of economists because it's kind of a
Mhm.
new business. They want to understand, how do we build this, how to price, and economists are experts in causal inference. And I see a lot of economists also start to use machine learning. So that's my assumption that why those companies are kind of embed those two disciplines better these days. So thanks for sharing the resources. And now, with all your experiences, you're looking at your career journey. What are some mistakes you have made in your career?
All of them. How much time you have? I've made some.
What is some, or like, what's some greatest lesson you have learned from your mistakes?
Uh, from a leadership standpoint, that concept of sources of authority. I've made the
Mm,
mistake of thinking that I was, if I just stayed the most technical person, the most productive person, I would be the best leader. And I didn't. No, something totally different. It's really understanding your sources of authority and continuously improving your sources of authority so you can lead without a title. I mean, that's the goal, is to get to the point where I could lead. You could call me, like, I could be the janitor. I could literally walk in with a mop into a meeting room.
mhm.
And from that, I'm mopping the floors. I could lead a meeting. And when you understand sources of authority well enough to be a janitor leading a meeting, you're ready to go. And that's the end goal. And I had a mentor basically say that. He said, you want to be able to walk into an office completely unknown
Mm,
and within a week establish a cadence, a rhythm, and be able to, in any scenario, contribute and help others contribute better, because that's leadership. You
yeah,
want to bring new knowledge, bring new capabilities in, and do that at every situation, every exam. And so those are the lessons, is
yeah.
those little pieces that lead to really big mistakes.
Hmm.
Thinking I could use technology to drive improvement in the business instead of using strategy to drive improvement in the business. I didn't get the point of business acumen. I thought, the engineer is the most technical. They should be the one who's leading all of these initiatives. Why are product managers here? Well, it's because you got to make money for this stuff. And I think there's a detachment from the understanding that everything we do makes cash. And if it doesn't, well, it doesn't have any purpose. So there are these other pieces of the business that are equally, if not more important. I think taking care of people as a leader, that's a mistake I've made, where I've begun to realize how important it is to take care of people, not just to lead people. And that a lot of leadership and trust is built by being good to people and taking care of them and leading them through adversity and being able to be an individual contributor when things are bad, not just when things are good. Being able to take care of your teammates even when you're not a leader, when things are bad, when things are hard, when projects are falling apart or layoffs are happening or whatever it is, when growth's happening and it's just chaos. You've got 15 new people and there's two people that understand what everything is, and they have to train 15 people, and it's just madness. And you have to be able to be good in those times when things are not good, when things are not easy.
Yeah.
And that's, if you want to talk about root cause of a lot of mistakes that I've made,
Hmm.
it's assuming things would be good and easy forever and not learning how to do what I do well when things are bad.
Yeah.
So I would say if I had to throw the biggest mistakes, those are the ones.
Yeah, thanks for sharing that. And I'm curious, previous you mentioned going to a meeting or join a new company. How do you, for example, what are the key elements of leading with authority? How do you build that?
Well, you have to choose a new source, and everyone has to develop a leadership style.
Hmm.
And so you have to work on what is your source of authority. Mine's strategy. I'm a strategic leader. And so I align everyone's goals to the strategy. I don't have to have authority. I can just say, I need you to do this because here's the goal. And if you don't do this, this goal doesn't happen. So I don't have to have a title. I need you to do this to support the outcome. I need you to do this to support core strategy. Why should you do that? Well, don't you want this to happen? Isn't that everybody's job? Isn't this your particular team's goal? Isn't this your KPI? Well, if you do this, the KPI moves. That's what you care about.
Yeah.
And so strategic leadership is the ability to come in, understand the organization, understand the structure, the objectives, understand the jobs and what everyone's accountable for, and be able to just align everything I do to support that. And so
Hmm.
anything I'm asking for is part of your job because it supports the objectives that you're graded on, that you get a bonus for, that you make a ton of money at the end of the quarter or the end of the year for. So that's really what strategic leadership is. And
Yeah.
if you're walking into any organization, it's that don't do anything until you have established everything you need to support your source of authority. Because if you do, you're just going to fall all over yourself. It's going to be bad, really bad. When you try to align yourself with something that's not supporting your authority. And a lot of people try to be the smartest person, the most technical person. I'm going to bang out of the gate, I'm going to hit the ground. No, you're not.
Yeah.
You're probably just going to make a horrible mistake.
Right.
So it's really that first week, just ask questions, be that person that
Hmm.
sits in the back of meetings and doesn't say anything.
Yeah. You don't have to like be the most technical person to lead a team. I think that's a lot of people kind of feel, oh, I don't think I can be a team leader because I don't know this and that. Yeah, thanks for sharing that. And you shared a great quote from your mentor. What are some other great lessons, great things you learned from your mentor?
Know what you get paid for. That's I learned that a little over 15 years ago. Know
Hmm.
what you get paid for. Never
Well,
take a
what does
job
that
where you don't
mean?
understand why you get paid.
Hmm.
Because that's a setup to fail. If you don't understand why they're paying you, you probably can't
Hmm.
do it very well.
Yeah.
So that's one just absolute golden gem. Um, Strategy without execution is the slowest path to victory.
Hmm.
That is something that I've come back to over and over again. Yeah, it's great to be a strategist, but people have to do that thing. So if your strategy doesn't make any sense from an execution standpoint, it can be the most effective strategy in the world. No one will be able to implement it. So, move on to do something else. Customer, if it doesn't make money, there's no point. So always have the customer in mind. If
Yeah.
they don't love it, it doesn't work.
Hmm.
And that was one of the best engineering principles I got very early on is if the customer doesn't love it, it doesn't work. It doesn't matter how well it works. If they don't love it, it
Yeah.
doesn't work. It
Right.
just, sorry. And, if you want proof of concept, some of Windows earlier operating systems, you look at some of this like Windows ME. Yes, it worked, but no, it didn't work.
Yeah.
It just, nobody liked it. Nobody wanted to use it. And you can bring something better to market that just crushes it.
Hmm.
And so those are the
Yeah.
types of lessons that I've really learned. And the concept of empathy and treating people well,
Mm.
that one's huge. Is just remember there's always somebody else there.
Yeah.
So when you're talking, you're not talking to yourself. And if you are, you probably need to seek some help. But you're never talking to you. You're never talking for you. There's somebody else there. They have objectives. And so if you look at every interaction as I have objectives, but they're not more important than the other person's. We're doesn't matter if I'm talking to Junior and I'm CEO. It doesn't matter. We both of our objectives are equally valid. And so if I sit down and talk with you, I'd better care about what you need out of this interaction because if I
Mm.
don't, that's me saying I'm better than you. That's just you can't start a conversation that way.
Yeah. Yeah. Thanks for sharing that. Those are really great advice. And I know now you are also teaching a course and you have your company. So, how do you see yourself grow? What you're gonna work on in the future?
I'd like to work on a boat, maybe sailing.
Hmm.
Yeah, I'm looking forward to retiring soon. I think it's time for me to go, and I've got probably about 5 or 10 years left,
What
and
do you
then
mean
it's
by
time for me
five
to
to
get out of
ten
the
years
way.
left?
What's that?
What do you mean by 5 to 10 years left in terms of your interest in the field, or
No, I
um,
mean, people at some point have to know when to shut up and go away because if our ideas are the dominant ideas in a field for too long, the field can't grow. The field can't mature. And so, whether your role is a small role or a big role, at some point you need to gracefully get out of the way
yeah,
and let new thinking, let new people build something better
mm,
because we at a certain point become anchors.
yeah,
And at some point you get out of the way and you just teach.
hmm,
That's kind of where I'm going right now is I'm
yeah,
making the transition to leading and teaching
yeah,
and eventually just getting out of the way,
right,
talking about how what I've seen is relevant to what might come next,
hmm,
but not being the person that shapes it anymore because
yeah,
that's the next generation's job. I've got, like I said, I
hmm,
got about maybe 10 years.
yeah.
And then it's time for me to just get out of the way.
And you might bring new insights to the sailing industry.
Yeah, I think I could teach a whole lot of data to
Hmm.
sailing, or if the San Francisco Giants are listening, if they need somebody to do analytics or data science, I got you. I got this.
Yeah. I hope they'll reach out. And what are
Me
some,
too.
yeah, that would be really cool. What
Oh
are
yeah.
some philosophies or lessons you learned from sailing that you have adopted to either your, data
Uh,
science or life?
Never turn your back on the ocean. I learned that surfing. Never turn your back on the ocean. And that's important for business too, because you have to understand the business operates in a larger market. It's not
Yeah.
just me, my board, and the next wave. There's
Mm,
more. And that ocean's powerful. And
yeah.
that's when you think about the marketplace. Never turn your back on the market because you can get so heads down into what it is that your company does, into your customers, into your competitors that you don't see the ocean. And that's unforgiving. And so, if I could give a surfing lesson, not so much a sailing lessons, never turn your back on the ocean.
Yeah.
And also know the limitations of your boat. I've seen people take boats out and yeah, that's not going to work.
Yeah.
that boat's not designed for that. You really shouldn't do that.
Hmm.
And Coast Guard, 45 minutes to an hour later, here goes the Coast Guard. I know where they're going. And so, know the limitations of your boat. Know your limitations as a sailor too.
Yeah. Yeah, that's great. What about the near term? So for this year, what are something you are excited about in your career or life?
I've got a couple of new clients that I'm working with, building out some organizations. That's always fun. The first 6 months with a client is always just a ton of fun because there's so much to teach, so much immediate value. That first 6 months, I look like a rock star, and then
Yeah.
the 18 months after it, everybody's like, "Why is this moving so slowly?" It's because just wait, just trust me, just wait,
Yeah.
it's gonna be
Mm,
good. And then that last 6 months of the 2 year engagement, it's like, that's why we're waiting. When everybody's like, yes, we got there, success. So that's, yeah, I'm having a lot of fun with that. Rolling out some new courses, hopefully over the next 6 months. I've been a little bit too busy to do those, so I'm going to do a little bit more focusing on courses, teaching, doing some of that. I might do a little bit more coaching. So those are some of the things that I'm looking forward to. So
Mm-hmm.
I've got a couple of cool projects that are coming up that uh, they're going to be good. Definitely going to have some fun with these.
Yeah. And for folks want to follow your courses or other contents you're creating online, where can they find you?
Datascience.vin. That's got every link to everything possible.
Mm-hmm. Cool. Thank you again for coming to the Data Scientist Show. I learned a
Thanks
lot
for having
from
me.
you.
Thank you so much.